Hello everyone, and thank you for taking some time to join Andrew and myself today. And welcome to today's session of Scan to Success. I would like to mention that a recordable version of this webinar will be available for you in the near future. We'll get it out to you by email or some way. As far as questions go, please enter them into the chat. We will address them as they are appropriate to the subject matter or at the end during the general questions portion. So please do not hesitate to ask questions. Please do so. I am Cameron Dodds. I am Vice President of the Industrial Scanning Solutions and Precision Surveying and Consulting. Our presenter today, I would like to introduce you to Andrew Picorni. He is our scanning manager for our Industrial Scanning Solutions group. His expertise comes from a combination of land surveying and 3D scanning. He has experience in new technology development, piloting, scale-up, implementation, and startup of novel technologies. With that, here is Andy Picorni to talk about Scan to Success. Welcome, Andy.
All right. Thank you, Cameron. We're going to start things off today with the general steps of the 3D scanning workflow. We'll then get into some of the details of each of the steps and follow up with some deliverables and different uses of the technology. So starting things off here. When we go out into the field for scanning, we'll chat with people on site or with the engineering service provider and walk down the area, figure out exactly what our target is that we need to capture and what items may be in the way or what stage of development the project's in. A little bit of communication to start things off and to visualize where we want to set up and how we want to work through the area. It's pretty critical. We'll get into a lot of these details as we go along. But anyways, we get on site, we set up the scanner in a bunch of different places, and we set and transfer control into the area to make sure that we're geolocated with the project. So everything that we create down the line for different deliverables is all located correctly and all works together with our scan data that we generate in the field. So when we get out with the field scanning, going station to station and capturing information, we generate a raw scan data file. And this raw scan data file gets imported into one of the programs that we use for registration, where we use control targets or control or the cloud itself using cloud to cloud to actually take those individual scans and put them together into a unified point cloud so that we can use it down the line when we export it out to the different programs that we do our modeling in. Some of the exports that we use is LGS files, RCP files, PTS, and a few others depending on which program we're working with. And then that point cloud will go into modeling programs in order to model the structures according to the level of detail that a project requires. We can also create surface models, and there's a few other uses that we have with that information. So we'll kind of get into some details of each of these steps as we go through, as well as share a previous deliverable that we have access to share to show you kind of how that workflow works in reality. So starting off to get into the details of field scanning. The scanning that we're talking about today utilizes LiDAR technology. The scanner that you have in the picture right over here is our P40. What that does is it uses time of flight lasers where it has a spinning laser and mirror inside of the center of that, and it sends out a pulse of laser light that goes out and it hits an object and comes back. And that P40 actually captures that laser data and generates an angle, a distance, and also an intensity of that light coming back. And that P40 that you see there in that picture actually captures 1 million of those data points per second. So that kind of gives you a little idea of the scale that we're talking as far as data. It generates a lot of information very quickly. And depending on a range that we're talking about, those scans can be, minute to 15 minutes if we want to, and it captures data at 1 million points per second that entire time. So there's a lot of potential data out of it, and obviously we're using multiple locations as we go through a site to capture more and more of it. So it's multiple setups with a lot of data. And we being surveyors originally, really made it a point to say that the information that we capture is all locked down and as tight and true to reality as possible. So we use survey tools in order to establish control throughout the site using traditional survey methods. We'll lock into a plant coordinate system or to whatever coordinate system that they have on site for the project, and add control points throughout our work area to verify that we're taking our resulting point cloud and deliverables down the line and fitting into reality. So not only is it designed within reality, but it also can be then laid out in reality using the control that either was pre-existing or that we expand upon into the work site. We also use targets to take the scans, the individual scans, and to lock them together with the highest level of fidelity that we can. And we place those targets in key locations to tie those together. I think minimum is 3 that we'd like to have in between each one for our purposes. You can get away with less, but we don't choose to. We use 3 or more targets in each one that can be seen with the next one, and so on and so forth. And like I said, those scans are taken in multiple locations to capture the line of sight of all the critical surfaces that we're trying to capture for it. I'll go ahead and pull up the project right here real quick. Let me know if this doesn't pop into your screen over there, Cameron. Looking good?
Looks good now.
All right, so here's a site that we scanned, and I'll give you a little example here. This is a large tank in the center here, and if we're just set up in one point, we can only see so much of that geometry on that tank. So we have to use multiple locations, scan locations, in order to capture more angles as we go around this entire tank. And so we'll kind of drop in a little bit here on one of these. So this here is an LGS file. Actually, that's one of our primary deliverables, and I'm opening this up in our TrueView viewer, which is actually a free viewer. So when we hand out this LGS file with this information, you have access to use this as you need. This file can also be brought into different programs to model directly on, and you'll see some of the tools that or some of the value that we can get out of it as I move along here. So this is a scan location that we have here. We have a control point down here that was surveyed. This is actually a PK nail that was shot using traditional survey tools. And we have these tripod targets that are fixed height, so we can capture information on the center of this. And we actually have all these red dots are locations that we scanned at. But it looks like we got another. This is just a control target, or not a control target, just a target for locking together that cloud between this and other scans. I believe there's some others. Looks like there's one here. I see one here. But we place them throughout the site, so we have at least 3 or 4 that can be seen from one station to the next. And you can kind of actually move through this site here and see different aspects of your site. It's almost like that Google Street View that a lot of people are familiar with, where they can go spot to spot to kind of see what things look like, except it's of the work site that you're trying to work on, and you can kind of visualize what the real conditions are on site. So you can actually share this information. Should you be on a Zoom call or Teams or whatever you're using, you can share this with people all around the world to be able to kind of plan things out as you go on a project. So there's obvious value to that. So that's kind of our general workflow that we have with that information as far as the field scanning. And then when we get back from the field, that scanner, we offload that raw scan data as captured of the individual locations, and we got to bring them all together into a single point cloud so we can model on it in real space. And we got to tie that down to the control that we established or transferred into site. So because each of those individual scan locations, all it knows is what's that distance, what's that angle, what's that intensity, and we've got to take all that information and turn it from a bunch of individual items into a complete picture of the site that we scanned, and then make sure we do quality control checks on it to verify that everything's aligning correctly, and then we all lock it down and georeference it to the coordinate system that we had out there. And we typically, or we usually use our Leica scanners. We got the P40, the 1,000,000 points per second scanner, very, very high highly regarded scanner. We also have a RTC 360. It doesn't have quite the range, but man, that thing churns out points at 2 million points per second, and some of the things with the workflow of it just make it scream through a work site. But there's other companies out there. Ferro's got some decent equipment. Trimble has some stuff. So kind of whatever your flavor is, and depending on what your objectives are, they each do things well. We found that our Leica scanners that we have done everything that we've asked of it and more, so we can't really complain about it. But because we use Leica, we register within Cyclone. We can also register in Register 360. Recap has some tools for registration as well, but with the scale that we're typically working on and the fact that we have Cyclone, we don't really use it too often, but it is a tool for a lot of people getting into the scene that doesn't have quite the cost paywall to get into a license of Cyclone or Register 360. Ferro obviously uses Ferro Scene. Trimble has their Trimble Works and some other tools out there. But anyway, so we register that point cloud together, those raw scans into a point cloud, and we export them. LGS file, that's the one we just showed there, and we'll actually bring that back up here for a few different things moving forward in this presentation or this webinar. But RCP, that's that recap file. That's Autodesk's point file that is pretty native to their programs, whether it's Civil 3D is a common one, AutoCAD Architecture, Navisworks, Revit. There's a whole list that they have, and those RCP files work pretty seamlessly between them, so that's a common one that we put out. PTS and PTX and E57 are kind of raw point cloud files that are pretty universal between programs. So that's one that also helps us get between programs at times, and also can be a good deliverable should the client or owner be unsure of what program they're going to ultimately use in the long run. So we talked a little bit about modeling earlier, but we'll talk a little bit more about it. When we get a project and we generate this point cloud based on the raw scan data, we can take that raw scan data or that point cloud and bring it into a whole range of programs to generate a 3D model of the work site. And it's important that when we do our modeling, we have a really good relationship and a lot of communication between ourselves and the owner, or ourselves and the engineering service provider, so we can capture the detail, the level of detail to the point that they need, and not so far beyond where we're wasting a lot of time and money detailing out things that don't need to be seen, but so we can invest that time and that expense into the areas that are really critical. So the communication is a big aspect of it. So you can't just take a scan site and just go run with it on your own. You always got to be communicating with your field guys. You got to be communicating with the engineering service provider or the construction management agency to know exactly what they want and what details they want to have in that. But we can also model out the surface, and there's a lot of things that you can use that for. A lot of civil deals, watershed or volumetrics of the dirt or rock or whatever you're bringing in. But you can also generate 2D and 3D CAD models with that information in quite a few different solutions that we got there. I'll actually go ahead and pull that LGS file up, because we actually are able to dump that model back into this LGS to kind of give you some more tools here. Let me go ahead and turn this point cloud back on. I'll turn the pano image off, and we'll go ahead and move around this cloud a little bit. So you can see this is the point cloud. This is what we put together when we take those individual locations that we showed earlier. We actually combine them all together into a single point cloud that we can move on and view a lot of things that may not be directly seen in one, but can be seen in a combination of views. You can actually take this point cloud that we can hand out and measure on it very accurately. I'll just take 2 points real quick here so you can see the information that we get. We got our plant coordinate system coordinates here, as well as the distance, and then all that information can be shared out as necessary. So we have this point cloud. We can do a lot with it as far as modeling. I'll actually go ahead and turn on our models here. You can see we have some of it has been designed upon the cloud here, and others are things that are designed into the space, we can actually see that as well. So models that are designed in the computer can be brought into this point cloud, so you can actually check, kind of your space use to make sure that you don't have clashes directly on this model right here. But you can also visualize what you're actually designing within the space, so you can make decisions back in the pre-engineering stage that otherwise may not have happened until they got out in the field and started trying to build the thing. So it's a heck of a lot cheaper to make a design change back in pre-engineering than it is once you have boots on the ground. So that's kind of a good ROI value point to share. But also you can use this to kind of move around and measure and just visualize the site as is. I think our 3D modeler got a little bit of, has a sense of humor. I think he put a Viking ship in here just to give me something to talk about here at this stage. But you can actually see, looks like we've got a shed over here that we can kind of turn on and off. But items can be added or changed as we go, and that model can be brought into this, so you can share it with your clients, or with the design team, or with the construction management team to really get a good grasp of the site. And it's all very highly accurate. I think that P40, has very good accuracy at range, and these models, or the scan data comes in typically within 1/8 of an inch, which is very, very high quality and with great detail. So, all right, we'll go ahead and move that off. I'm sure you guys can all think of different uses that you have of that kind of information. But all right, so you've seen a model. I didn't feel like snagging like 10 grand worth of licenses for this, so I just snagged a couple screenshots of a few of the programs that we model in, so you can understand what data outputs you can get. We got AutoCAD Architecture here. That can ingest our LGS file using the CloudWorks license, or it can ingest that RCP file that we talked about earlier. AutoCAD Plant 3D here, another common one. Helps out with some of that modeling and some of those pipings and a few other things. One of our primary modeling locations is actually going to be directly in Cyclone. When you're working with the full point cloud as it was seen from the scanner, instead of down the line after a couple exports, you don't have any of that decimation of the cloud, and you can really get in and get some details that you may not see down the line. So that's a very great tool for us. A lot to learn. It's kind of the Unix of modeling software, where it's incredibly powerful when you know it, but it can be very difficult to learn it. But once you know it, it's a great tool to work with, and that's one we really like to use. Navisworks, obviously Autodesk solution. We can bring those RCP files into there and work with that whole suite. 3ds Max can get you some very good details on different objects. Revit, very good kind of plant or overall site documentation, great with BIM. And also some additional uses of that point cloud beyond just the modeling is you can get your stockpile quantities and different volumetric numbers. Also, one that gets brought up a lot is actually for like tank deformations, so deformation analysis. You get some of those large high volume tanks, or working with some high volatility materials. You can see settling or different deformations in there, or leaning or whatever, and we can capture that information at a very high resolution. So you can get a lot of very good information on it to know, exactly where you're bulging or sagging or settling, and track it, the entire tank, instead of just maybe the settling or the base of it. You can track the entire thing over time and see how it's changing, maybe even different seasons of the year, hot versus cold, or full versus empty, how it changes. So you can understand what the wear and tear is on it, when it needs to be decommissioned. There's a lot of uses for that. Also, that point cloud can also be used directly against a BIM model as it's designed, so you can do clash detection with it, or verify that the model works within the space that you have. You can also do inspections on it, like I mentioned I think earlier with the construction management agency, getting a scan to verify that the site was built as intended, and get that inspection of different aspects of it before those subcontractors get their final contract signed off on. So that's a valuable tool right there for a construction management agency.
I'm going to stop you here. We had a question from
Sure.
Eaton out there. Can you model underground piping?
Oh, you can model underground pipe. That's a very good question. I actually have that in the LGS file here. So if I move around just a little bit here, not only do you have your above ground as-built models here and your proposed models, but you do have the ability to capture some of this underground detail. Maybe it was surveyed out at one point in time and you have information on it, or coordinates and size and type. We can actually take that information and model it out, and you can view and kind of move around all these underground. So it actually looks like we got a great inlet right here and some piping going to it. So there's some additional things we can do actually where we invert our scanner on a tripod that cranks down into manholes where it can actually catch the bell of it and see the actual inlets and the flow lines of everything and model that out as well. So kind of your limitations are really kind of your imagination with this this tool. So that's a very good question. Thank you. So and getting back to this. Oh, there we go. When is 3D scanning most valuable? Kind of our big one that we do that gets the real big scanning. It's kind of that, you know, things that you really talk about for a while here over here at Industrial Scanning Solutions would be those bigger facility upgrades and additions. You start getting some of these facilities, you're talking, you know, a couple thousand scans potentially, and that's, you know, big data right there. That always kind of gets me a little bit excited when we start talking about those bigger projects. But 3D scanning is most valuable when you have your larger scale projects. We'll talk about some of the benefits, but if you're talking about getting, you know, 5 to 7% return on investment on it, you know, if you're talking, you know, a $1 million project and you're getting 5% return on it, but you're spending $100,000 scanning, you know, it doesn't make sense. But if you're talking a $50 million project, then it really makes sense to spend that money to do it. Now, obviously, a smaller project means less laser scanning and less cost to it, but that's an example of understanding what as you scale up in a project, there's more opportunity for that return on investment with 3D scanning, and, you know, industrial facility upgrades and additions are a big one to really push 3D scanning, just because of the fact that, you know, the cost and just the sheer volume of data that has to be captured, because, you know, with pipe routing or structural steel, or so many things can be in the way. It's a valuable tool in the belt for an engineer to have that kind of information to design on, so you're not dealing with as many problems down the road, and everything actually fits correctly. You don't have to move things around or, you know, do custom fits in the field as often, and there's a lot of potential value with that. Also, you know, in your construction, your typical commercial construction, or, you know, other types of construction, pre-engineering typically goes a lot smoother when you have that 3D point cloud and that actual understanding of what the site is. There's oftentimes a lot of communication loss between the field and the office when you start working with these engineering teams. You know, you send out or hired a surveying company to come in to capture this information, and then maybe something's missed, or details are lost in translation when you're talking between the surveying company and the owner and the engineering service provider. When you have a 3D scan, you can see dang near everything. So there's there's a potentially more you know, streamlined workflow there when you're using 3D scanning. And also, you can get documentation as you're moving along a construction project to show the owner, from the construction management agency, they can show the owner that what the owner is paying for is actually being built, and if there's an issue, they can address it while the contractor's still on site. But also, at the end of the day, the construction management agency can go to the owner and say, here's this documentation, this is where everything is, you know, we can close out because we know for certain that everything is how it's supposed to be. And that's a very valuable tool down the road. Say a couple years later, something comes up and they say, hey, you know, how can you prove that you actually built it the way you said? And now they can fall back on the scan data and say, here it is, you know, here's what we built exactly as it was, and you know, you got what you got. So also, documentation in high-risk areas is a good, valuable tool with laser scanning. We'll talk about it a little bit more as well, but the fact that we can capture data from a distance allows us to get out of some of the pretty hairy areas that you might find on a work site, you know, with a lot of traffic or moving equipment, or or some hazardous materials that you might find on a work site. I appreciate it as a, coming from the surveying background, we got into some areas in the past that, you have to spend a lot of time, to appropriately tackle it as far as safety. And with the scanner being able to hit that information at a range is a valuable tool for us. I think we talked about tank deformation enough already. Volume calculations and kind of surface geometry is valuable. Collision avoidance, clash detection, mentioned that a little bit with the BIM modeling and checking that against the point cloud, as well as pipe routing and centerline analysis. We'll get into some of the details of the benefits. May have already talked about some of this a little bit, but you can see increased profitability on a work site as much as 5 to 7%. And that obviously scales and depends on how you're using it and the level of familiarity your engineering service provider and construction agency has with it. But we've seen that time and time again, especially on industrial sites, it makes a big difference. Also, your profitability, if you're on an industrial project, reducing the schedule is a big part of it, because shutdowns are expensive. You're talking about potential millions of dollars a day lost, and you get in and take off a day or two off of a shutdown, and it's paid for itself in just that alone right there. But also your improved project planning. With that rapid data acquisition and that complete site data that you get an accurate representation, and you can really improve that communication, like I said earlier, between the person capturing the data and the owner and the engineering service provider. When you have a complete picture of your site, that communication stream right there gets streamlined, and it really helps out with project planning. Also, like I said, decreases downtime. It can be, in most cases, a site can be scanned while it's operational, so you don't really have to stop work or stop productivity while you're capturing the information. There are some scenarios where there may be a lot of moving parts, or if you're talking about the inside of a tank that's normally full, obviously it has to be empty for us to get in there with the scanner. But in many cases, that site can be scanned while it's operational, or scan the majority of it and then get into the critical areas and really reduce the amount of time that has to be shut down in order to capture the information. Also, we talked about the safety risks of it. Capturing from a distance reduces our exposure to hazards like radiation or high traffic, high voltage, or other hazardous materials. So that's nice coming from a data collection standpoint. It also reduces your construction management risk. We talked a little bit about BIM model verifications and talked a little bit about catching deviations before contract sign-off. So there's a lot of potential value there. It also reduces the number of times you need to return to the site in order to capture more information, because you do capture, even if your goal is, like we showed earlier, that tank, we also captured all those things around it, some overhead pipe racks, or some pumps, or the buildings in the area, and the surface geometry around. And by capturing all that data, while you're going for one thing, when you come back and find out you need to get something else, you've already captured that data, and a lot of times you don't have to return to the site in order to use that effectively, in order to kind of streamline that project. So there's a lot of value there. But for the sake of just telling you all the sunshine and rainbows about 3D scanning, I mean, there are drawbacks. The first one would be that upfront cost. The high-level scanners like what we use, they cost $30,000 to $100,000 up front to get it, and the different accessories that you need to get with it, as well as there's the yearly maintenance cost to keep everything running at the just highest level of detail and highest level of accuracy. Maintenance costs are sometimes more $1,000 a year for maintenance. And that processing software and that modeling software, those licenses can cost $5,000 to $20,000 a year, depending on what your exact license requirements are, and depending on what program that you're using to register and model that information. Also, the employee skill sets, that's a big one. Some companies are hesitant to get into it just because you don't know what your existing employees are capable of doing. And point cloud processing is a very unique skill set, and training on it, I think we quoted out not that long ago for like $7,000 for like a 2-day Zoom call, basically to go through some of these programs. I mean, it's significant. So that's a drawback. Also, modeling in multiple programs means that people need to understand. There's more training with more programs, but it is important to understand multiple programs when you're talking about modeling, because some programs do things very well and other programs do other things very well, and making sure that you're most efficient using the program that works best with what you're trying to capture is an important tool to have in any 3D modeler's tool belt. So also, you got to be able to understand complex, instrumentation drawings or plan sets, as well as, create those plan sets if you're modeling it. Also, the computers that we use, I mean, there's some pretty cool computers, but man, they're not cheap. You're requiring a high-end CPU typically. I think our processing computers are around like 256 RAM. You can get down to 64 on some of the smaller scale ones, and a solid graphics unit, which those are hard to come by right now, but and kind of costly right now compared to what they should be. But you want to get too far into that one. But it's important to invest in the computer that fits with the needs that you have. It doesn't make sense to invest in some $20,000 computer or $10,000 computer if you're just using it for smaller projects or with lower level modeling. But as you get to larger and larger projects, you're going to need to have something that has a little bit more processing capability, and so kind of custom tailoring your computer to fit your needs is pretty critical. So you're spending in the right areas, and there's a whole list of forums that can get into what's needed on what program and what, and those utilities or those resources are out there if you just kind of look for them, or you can reach out to us and we can chat with you a little bit about that. But also with those larger projects, there's a data management cost. Smaller projects typically can take 10 to 50 to 100 gigabytes, but some of our larger projects, I think we got done with one about 6 months ago that was pushing like 50 terabytes when you start talking the raw scan data and the register point cloud and some of the downstream deliverables. So managing that level of data is something that takes some expertise and an investment in technology, and also an understanding of data security, so that all that information is secured and it's housed in a way that can be accessed, appropriately, isn't disseminated out, or you always worry about data getting out to people that shouldn't have it, and that makes data security something that needs to be thought about at every stage in this process. So that's kind of the drawbacks of 3D scanning, but kind of sum things up. 3D scanning and modeling can be used for kind of a ridiculous number of purposes. The ability to visualize all aspects of a work site to such like a high detail and level of precision allows us to really generate whatever you guys need. This opens up a lot of opportunities to see that return on investment. It's not just one direction that we can go a lot of different directions. And with the knowledge, technology, and personnel that we have today, we can really make 3D scanning technology work for you no matter what your needs. Now, Cameron, do we have any additional questions over there in the chat, or is it just the one that we addressed earlier?
We do have one from Francis.
Okay, Francis, what do you got?
The question is, have you had the opportunity to scan and model a substation?
Have we gotten the opportunity to scan and model a substation? We have, not the biggest one in the world, but some of our industrial clients, that's kind of our primary area, which we've gone out from, but they all have substations on their site, and they all know that it's important to capture all that information. The fact that oftentimes we can capture it from outside the fence, but if they want some details inside, we can get in and through all those structures inside and detail that out. So we have, and it's a very valuable one. I know traditional survey tools, whether it's GPS or others, can oftentimes have a little bit of difficulty functioning in that environment with the high voltage and the interference that they can have. And also, I personally wouldn't enjoy getting up close and personal with some of that equipment. So it is something that is a big opportunity for 3D scanning to really push in the long run. We also do a little bit of drone work too, so if we're talking like transmission lines or things like that, we can, we got LiDAR drones or photogrammetry that we can use to capture that information very rapidly. So the solution that you use as far as modeling or point cloud generation is really something that you want to custom tailor towards the environment that you're trying to capture. But that's a very good question, Francis. I appreciate that.
I don't see any more on here on the open question and answer.
Okay.
I didn't know if you wanted to unmute them to see if they wanted to verbally ask questions, or...
Yeah, we can do that real quick here. Let's see. I'll have to kind of pop this out a little bit or kind of figure out how to work this some.
Oh, I got another question.
Oh, you got another one?
From
Okay.
Eaton.
Okay.
What might be the turnaround time for a scanning project with, say, a house-sized building?
House-sized building. Well, I mean, it's going to depend a little bit on the detail that you're trying to capture. If you're really trying to get in the nooks and crannies, that's going to require a little bit more. But typically, if we're coming in through, generic house requirements, 1/8 inch kind of accuracy, to get in and scan it, I wouldn't expect to take more than 4 to 6 hours. Talking about getting control in there and transferring and moving around, and depending on whether or not we're using the P40 versus the RTC360, we can kind of get in and get out and then come back. In the registration of that, if you're talking about registering less than 150 scans, we can usually get in, get that imported in overnight, and then get it all registered over the next day, and then maybe work on it a bit, quality control checks and whatnot the next day. So the turnaround's pretty quick. I'd say less than a week on all that, and then we can get into modeling, and that gets really detailed on what level of detail you're trying to capture on that. So good question. All right, let's see if I can figure out how to unmute everybody here. All right. Okay. Find it here. Here's our participants. Okay, I'm going to allow everyone to talk here, so if you have anything you'd like to say, I'm being very open here, I guess, to everybody. So if you'd like to unmute, you can and ask a question. I just ask that you keep it PG, or PG-13 at the very least. So open it up to everybody.
Yeah. Also, feel free if you do come up with questions after, you can email us, through our regular emails. We'll answer those questions as well.
Mm-hmm.
So.
Yeah, and I know Zoom has some tools they have to house this video, so we'll probably house it on the cloud. But we can also, if you request, we can probably send you a link through a Google Drive link or a share file or another, whatever you guys need. We can send out that video if you want to share it. We'll also probably post a link to it on our website. That's iss-3d.com. You can check that out for some of the other things that we do. I think I mentioned the drone a little bit. There's also some tools that we use as far as ground penetrating radar. We actually got to go out and do some bathymetry where we used a drone boat with a sonar mic. So there's some other things that we can do that are pretty cool that we can also discuss with you, what makes sense for what you're asking for in a project. Don't want to think that we're just here trying to do a sales pitch. We're also trying to educate a little bit. So if you got questions, feel free to email it to us. I guess with that, looks like everyone's good on their questions. Well, I guess we'll kind of close it out. You got anything you'd like to add, Cameron, before we close out?
No, just thanks for taking your time and joining us this afternoon.
Mm-hmm.
We appreciate it.